Now, in this video, we are still going to be talking about exponential growth, but I'm not going to be giving you the formula. We're going to need to figure that out. So in this example, we have a culture, and this is what we know. So the culture doubles in size every 5 days. The question here, first part, is find the rate of growth. And you might say, how do I figure that out? You didn't give me enough information. Well, I did, because the key pieces of information are the fact that it doubles every 5 days. And one of the formulas that I gave in the previous video is this. If you want to talk about the time it takes to double, all of this stuff is connected by this formula. The natural log of 2 equals k times t. So in this formula, natural log of 2 is just a constant, and I'm telling you that the t is 5. So that means that my k value is going to be the natural log of 2 divided by t. So that's the natural log of 2 over 5. Now keep in mind that is an exact value. But we want to come up with some kind of approximation so that whenever we work this, we are just kind of working with a decimal, and we have something a little bit nicer to see there. Okay, so we have natural log of 2 divided by 5. And so this tells me we are approximately 0.1386. Okay, so that's going to be my rate of growth, which means that we are about 13.86%. Okay. So this next part here is saying that if the initial mass is 170 grams, so that means the initial mass, so N naught, is 170 grams, write a function that describes the culture's mass based on however many days it's been growing. So that means my function n of t, the template here is n naught e raised to the kt. So that means my function, the initial value is 170, e to the, we're going to, that's the k value we want to use. We don't want to use the percent, we use the decimal. So 0.1386 times t. So that's the formula that we will use. The next part here says, what will be the mass in 9 days? Well, we know that it doubles in 5 days. So in 9 days, that's almost enough time for it to double twice or to quadruple. So kind of keep that in your mind. If I were to quadruple 170, I would have 680. So my answer won't be quite that, but in the 600 range sounds about right. So this question is asking, what's the mass in 9 days? And again, this is where we need to go over to the calculator and have it do the work for us. Right? We can't just throw that into a 4-function calculator because it just won't give us anything good. So yes, I've got a bit of rounding going on here. And typically I would say keep all of that decimal, just kind of store that in for x. But here, I'm just going to round to 4 decimal places, and that's going to be, as they say, good enough for government work. So 170 e to the 0.1386 times 9 power. Now, the way that the calculator is displaying this, it's all in the power, so I don't need parentheses. And we end up with a value that is approximately 592 grams. Now, I just want you guys to see something real quick. If I'm in the mode here and I go from math print, which is what you've been seeing, and I go to classic mode, then whenever I do 170 and I do e raised to the power, notice that it opens up parentheses for me and it's not giving me the superscript. So when I go 0.1386, if I close parentheses, that means that's not going to be what we want. We want to do times 9 all inside that set of parentheses. And we get the 591.8 or 592 when you round. All right, this next piece is asking, how long does it take to triple? So we knew how long it took to double. That was 5 days, and we didn't know the K. But now it's asking us how long does it take to triple. So that means we don't know the time, and we have to know the K. But we already do know the K, because that's related to that guy right there. So when we had the doubling time, we said natural log of 2 equals K times T. For tripling time, we just make the slight adjustment and we say natural log of 3 equals K times T. So solving for T, the natural log of 3 divided by K. So natural log of 3 divided by 0.1386. And let's find about how long it takes for things to triple. All right, so we have the natural log of 3 divided by 0.1386. So it tells me that it takes about 7.93 days to triple. Okay. And again, it's coming from this nice little formula right there. Now, another way of doing this is that you could say, oh, well, in order for it to triple, I would be triple 170, which is 510, and you would take this basic form that we have, and you would have to then solve it for T. Well, the first thing you would do would be to divide both sides by 170. Those guys reduce. On the left side, you have 3. On the right side, you have, jumping ahead, e to the 0.1386t. And when you take the natural log of both sides, you're going to see something that looks very, very familiar. So we'd have the natural log of 3 is equal to 0.1386t. And we would divide both sides by t, and you end up with something that looks just like that. Okay. So it's, again, let's use the shortcut, right? The long way is still going to work, but learn the shortcut and know how it operates, and you can make very quick work of these problems. Now, the last part here asks, when will the mass be 450? So when will the function value equal 450? Well, that's pretty much like the last thing that I showed you right here, except having 510, because we're talking about tripling, we're looking for a very specific value, which is 450. So we'd be solving 450 is equal to 170 e to the 0.1386t. Really, you do one of these problems and you've done them all. They don't really change too much on us. So we have to divide by the 170 first, so that we can get the exponential piece by itself. I would suggest that we reduce that guy by 10. Again, that's a nice, easy simplification to do. And then e to the 0.1386t. And yes, throw the natural log up here. So the natural log of 45 over 17 equals 0.1386t, and divide both sides by what is essentially here our rate. So 0.1386. So my time is approximately, so what do we have? We have natural log 45 divided by 17 divided by 0.1386. So the time is about 7.02 days. All right, so that's the algebra telling us what it is. But let's check with the graphing calculator. So we have here 170 e to the 0.13886 t or x. And then we want to know, when does this equal 450? So if we graph this, well, you know what? We're not going to see anything because my window is no good. So let's see my window. So 0 to 10 is probably good. The y min, the smallest it gets is going to be 170. And we're trying to go up to, let's see, what did we have before? So it triples in almost 8 days, so that would be 510. Let's take this up to, say, 650. Yeah. And let's make this every 50 units. This is what the graph looks like. So there's the exponential. And then we have the constant function right there. And we just want to figure out where will these guys intersect. So second, trace to the calculate menu. 5 to intersect. First curve is good. Second curve is great. Guess, close enough. And it tells me 7.02, which is the same thing that we have down here. Now there is another way to do this. So if we quit out of this, and we go to math, and we go to the solver. Okay, so I would say that for the solver function, it's better if you change your mode and go back to the math print. Oh, you don't like that. So when I go to math, and I'm in the math print mode, and I do the solver, it tells me equation 1 or equation 2. Right? So I think we could just say, I want you to grab the first equation, and I want you to grab the second equation. And solve this. Oh, nope. Maybe I shouldn't be doing it this way. Yeah, you know what? This is probably not the best thing to do. Let me come back up here and let's do it the right way. Thought I knew what I was doing, but clearly I don't. All right, so we want this to be equal to 450. And we wanted this one to be 170 e to the 0.1386. And there's our solution. Yeah, again, 7.02. All right, so a lot of different ways we have of solving this. So kind of pick your poison if you get to use the graphing calculator.